Hi, good day. I'm Ravi and welcome to Developer Ramp Up. Today we are going to continue to look at Golang from the point of view of a C# developer. In particular, we are going to look at structs in Golang. As usual, we're going to look at a C# program and then write it in Go. So on my right here, I got a simple C# program. We are declaring a struct of an employee. We got some properties and we got a method. And to create an instance of the employee, you would basically new the employee and then you can call the method on the struct. And if I run this, you're going to say prima the name of the first employee, and we are calling the method and it's processing payroll. I can replace the struct with class and the code would work exactly the same. So even though there are some fundamental differences between struct and class in C#, we are not going to go into that today, but for the purposes of looking at structs in Golang, we're going to consider we can use both class and structs in C#. Now let's do this in Golang. The first thing is Golang does not have the class verb at all. So Golang doesn't have class. So we have to make do with interfaces and structs. We will look at interfaces in a later video. Let's concentrate on structs today. Okay, let's start. So to define a struct in Golang is pretty much very similar to how we do in C#, except some syntactic differences. Basically go type employee struct curly braces, and then we start defining our properties. So we say id int first name string, last name string, age int, and that's pretty much it. And we can, to create an instance of a struct, you basically, we can, it's very similar to how you would normally do with any type. So we can say emp1 colon equals, and then you can say employee braces, and then you can start assigning values. So you can say id id is 1, first name is first, last name is first, let's say emp1, and last name is emp1 as well, and age something, and we can print it fmt.print emp1, and let's run that. And so we have a struct and we created an instance of the struct and we just printing it out. There's a couple of different ways you can do the same thing in Golang. So this is basically called, we are using a structure literal. AL, I think. And another way to do that would be you can use the dot notation. So you can say var emp2 and employee, and then you can go emp2 dot first name equal to emp2. So now if you print that, uh, so another way, so these are the couple of ways to do the same thing, but there is a variation to that which is slightly different, which uh, based on references or pointers. Um, so the third way to do it would be emp3 colon equals, and you can use the new keyword. So you can say new of employee, and you do pretty much the same thing. So this, so here employee 3, and let's change this to employee 3, employee 3. Save this and run it again. You get C. But you'll notice there is a slight difference to the third version. So the first two things are pretty much doing the same thing, except syntactic preference is how we prefer to write it. This one is actually different. So this one is giving you a reference to the object rather than the object itself. Um, Basically, EMP3 is now has a reference to the point in memory where this employee object is being stored. And the second thing to note is when we use a new, it allocates a zeroed storage. So it's not actually allocating storage in memory when you do this. It's basically creating a pointer in memory, so when it needs to actually store some values, it will allocate memory, but at this point it's only creating a zeroed storage. So there is no cost to doing a new, and you can postpone the cost of allocating storage to a later point. The other way to do the same thing in another, again, this would be a syntactic preference as well, emp4 colon equals to, and instead of using the new keyword, you can say ampersand employee, and do that, and then you do pretty much the same thing. I'll copy those lines of code, and emp4, and it's emp4 as well. Here you go. So this looks exactly the same because it does the same thing. It's a preference of whether you want to use this syntax or this syntax. Using this syntax, you also have the option of assigning variables upfront. So if you can say first name and emp, you can straight away say emp4, but that would mean you're going to allocate storage at that point as well. So it is pretty much the same thing, whereas the storage gets allocated when you create emp4. Here you're postponing it until you actually need it. Okay, so that's various way of creating an instance of a struct. And what about the method? Adding a method to a struct in Go is slightly different to how you do it in C#. The way to look at it would be adding a method to a struct in Go is similar to extension methods in C#, where the definition of the method is not actually part of the class, and you do that separately. That's an equivalent structure here. So let's create a method against an employee in Golang. So to do that, you do it outside of the struct. So basically define a func, and you have to say what are you adding the method to. So we're going to say e and star employee. Bear with me for now. So let's say the same thing. Process payroll, and this function returns an error, and here we say fmt.println processing payroll, and save that. Why am I getting a squiggly line there? Oh, I'm not returning anything because it expects me to return something. Return, I'm going to say return null. So, okay, there are a couple of things to unpack here. So, this is the struct we are writing the method for. So, employee is the struct we are adding this method to, and it returns an error. We will look at Golang functions in a separate video, but Golang can return more than one return value at the same time. So in this case, and it's returning an error variable, and if there is an error, we can create an error instance and return the error. If there is no errors, it returns a nil. So let's get rid of these things. We don't need it anymore. We just need one way of doing this. And to call a method in again, if in the struct, you would basically do emp1 dot process payroll, and because it returns a value, so error colon equals to process payroll, and we say if error not equal to null, we are going to write fmt.println error in payroll processing. Otherwise, we basically end the code. So let's clear some space here. So we are processing payroll and we are returning nil, and so we are not getting into this control structure, and then the code ends. So that's a way of attaching a method to a struct. So you can add as many methods to a struct as you want, and with this, right, like C extension methods in C sharp, this method doesn't have to be in the same package as your base class in C sharp. So this could be in one package, and you can add methods to that base file type in a different package. That keeps it really flexible, and so what else can we do? So let's talk about the errors a bit. So functions in Golang can return more than one thing at the same time, right? So we will look at that in a bit more detail in another video. But what happens if I want to return an error? So instead of nil, I can say errors dot new, and we can say payroll. So we can say payroll processing error. So that's complaining because I don't have the package. So let's import the package, and so this, and here I can say if error is not null, I can actually say error dot error. So now if I run this, so it's going to go processing payroll, and it we return an error, and we're displaying that. And that's another fundamental difference between C# and Golang is Golang does not have a concept of throwing exceptions. You have to return the error as a return type, and that makes a fundamental design choice when you're writing code. You can't throw an exception and catch it somewhere else globally. It needs to be handled at every point a function gets called. That forces you to think about what, at every point you're calling a function, forces you to think about what you want to do in case of an error. So that makes you write more accurate code, and you can't depend on global error handlers like we do in C sharp. So that's pretty much covers structs in Golang. Um, and let's finish this for at this point. Thank you for watching, and please subscribe to continue our learning or Golang using C# as our base platform. Thanks. Bye.